Hello, everyone. I want to welcome you to this webinar. This is a Apex.AI, SYSGO, and Renesas joint effort. We wanted to show you something that we've been working on. So welcome to this webinar for the next generation platform that combines robotics, AI, and real-time with automotive certification. So the agenda today. So as you know, the Automotive E architecture, they're moving to centralized and zonal as the vehicle functions are moving from discrete physical components to virtualized software. We will be showing you and demonstrating a solution for how you can quickly develop your software-defined vehicle and achieve ASIL D certification. So today we'll talk about who we are, the joint solution, what each of us is contributing. We'll make some conclusions, and then we'll open it up for questions and answers. So Apex.AI, we are a ISV, we're a software company. We specialize in developing automotive grade software based on the open source. So Apex.OS, we help develop open source ROS2, and we fork it and we harden it and certify it to ASIL D. And the Apex.Middleware, which supports both the ROS2, the Apex.OS, the adaptive AutoSAR, and customer frameworks as well. And so we're really all about making automotive software safe and making it very fast and easy to develop it.
SYSGO is the leading European vendor for embedded operating systems. We were founded in 1991 and are part of the Thales group since 2012. Our main products are the hard real-time operating system and hypervisor PikeOS, and the embedded Linux distribution Renesas. With its certification kits, PikeOS supports highest safety and security standards like ISO 26262 ASIL D and common criteria EAL 3+.
So Renesas, who are we? So Renesas is a leading-edge semiconductor company with a wide portfolio of devices from analog, power, microcontroller, and SoC devices. Our main focus is on the automotive market, and where we have significant market share with products such as RH850 or R-Car. Since 7 years, we have been investing in ADAS and autonomous drive, and we developed new ASIL D SEooCs with cutting-edge deep learning performances.
So trends happening in the automotive EE architecture. We're moving from distributed architecture with lots of MCUs to domain-based with ECUs and MCUs dedicated for each domain to centralized and zonal architectures. And on the software side, what's been happening is if you look at what happened in the mobile space as you went from hardware-defined software to software-defined smartphones, you had the emergence of these base OS and SDK, the base software, which enabled the creations of millions of applications. And something quite similar is happening in automotive as well. So as we move from the hardware-defined vehicle to the software-defined vehicle, it is having this base software and SDK that's going to allow the rapid creation of many vehicle applications. And so what is ROS? So Robot Operating System is a flexible open source platform for developing and prototyping applications. And a lot of people think of this in terms of autonomy, and certainly for the automakers, today, most automakers are using ROS in ADAS and autonomy prototyping, okay, in their R&D. And this is a huge developer community. There's millions of ROS users and developers. We have like 500 million ROS packages downloaded a year. And it's what's taught in universities. So for automakers, where can they get skilled developers? They get them from the university. And the other trend that's coming here to automotive is this cloud native. So how do you bring cloud style DevOps to the car? So you think about, you develop your code, you build and test it in the cloud, and then you deploy it to the car. And so with ROS, what we do with this solution, we show you how you can go from these prototypes from your R&D environment to production with this joint solution that we have developed together.
So these joint solutions, we are leveraging our company assets in order to build a complete solution along the different layers of the complete vehicles. Each individual component or layers are developed being aware of the constraints forced by the complete system to ensure a coherent solution matching the expectation from Tier 1 and OEMs. Taking the example of electrical vehicle, Renesas provides solutions for electrical engine and battery management. We also provide solutions for sensors, actuator, and central compute platform, which is the main topic of today. PikeOS from SYSGO offers a unified software platform focusing on middleware and infrastructure. And last but not least, Apex.AI offers software-first solutions, enabling OEMs to develop functions independent on the hardware, while enabling a tailoring of the hardware to maximize OEM software assets.
Here we would like to introduce our envisioned joint solution on a software level. If it is on a heterogeneous platform like the Renesas R-Car VH4 or on a homogeneous platform like the R-Car H3E, the joint solution will provide the basis for safe and secure automotive applications, from ADAS and autonomous driving to telematics and connectivity to infotainment, from prototyping to certification. On the left side, we see a setup that combines PikeOS for MPU on a real-time CPU of the Renesas R-Car V4H with an AUTOSAR Classic application for motion control. The complementary ADAS applications are integrated on the application CPU cluster. These are implemented with Apex.OS cert running on a PikeOS hypervisor. The data distribution between the CPU clusters is provided by Apex.Middleware, for example, via some IP bridge. On the right side, you can see a setup on a Renesas R-Car H3E. Here, PikeOS integrates applications of different criticality in separate partitions. The applications of higher criticality are strictly segregated from the ones of lower criticality. This allows the integration of widely used QA-level components, here for example Qt, on a SYSGO Linux, alongside of certified components. The demonstration we want to show today is based on the LiDAR perception stack demo developed by Apex.AI. LiDAR sensors capture the surroundings as three-dimensional point clouds. Each point in the cloud is located in space relative to the sensor where its laser is reflected by a surface. In this demo, we replay raw point cloud data that was captured by two LiDAR sensors on a test drive. The captured data is processed by a set of Apex.OS nodes with different responsibilities. Depending on their task, each node publishes and subscribes to different categories of data in the Apex.Middleware network. These categories of data are known as topics. The driver nodes for the front and the rear sensors convert data from the captured raw format into a format that can be exchanged between the nodes in the network. The filter nodes pre-process the data published by the drivers, applying distance and angle filters, as well as executing a static transformation. From there, the data follows two separate paths. The block store node on the upper path fuses the pre-processed sensor data from the two sensors into a single point cloud. In this demo scenario, we assume that the data published by the block store is not critical. It is only used to provide visual context for the viewer. The critical data is published by the actual object detection run by the two nodes on the lower path. The ground filter node separates non-ground points from ground points because you can only collide with objects not on ground level. The detector node, here a combination of three algorithms, detect higher density clusters in the point clouds and converts them into bounding boxes. These bounding boxes represent the detected solid objects. Although both paths contribute to the visualization of this demo, it can be imagined how the topic that is publishing the detected objects is used as input to further processing like motion planning algorithms, while the other one is not. You may have noticed some nodes I did not mention here. They are optional in the LiDAR demo and not used for this demonstration. This figure shows how the Apex.AI LiDAR demo is integrated with PikeOS on a Renesas R-Car H3. The captured raw data is replayed by a PikeOS native application that you can see on the left side. The nodes shown in the previous slide can also be identified here. Some of them have been consolidated into single applications that share the same Apex.OS and POSIX layers. The remaining nodes are segregated into separate partitions of the PikeOS hypervisor. The data distribution network over which the topics are published is connected to the outside world by an Ethernet driver that additionally acts as a virtual switch between the partitions. The visualization tool, RViz, you see on the right side, running on an external machine, subscribes to the topics published by the block fusion and the detector nodes. We will now show some video footage of the RViz output generated by the demo. Here we can see the visual output of the LiDAR demo in the RViz tool. At the center you can see the representation of the car that captured the data. It is surrounded by the visualization of the raw point clouds symbolized by the colorful dots. You can make out objects like cars, trees and buildings in the negative space of these point clouds. They provide visual context of the recorded data to the viewer. The detected clusters in the point cloud are published in a separate topic. RViz displays them as the gray blocks. They represent the critical information in the data distribution network. Notice how they match position of negative spaces left in the point cloud. Considering that the block fusion node would be of lower criticality than the remaining nodes, the joint solution would allow the block fusion node to be certified at a lower ASIL. If the node would fail somehow, as shown here, the robust partitioning ensures freedom from interference, keeping the critical path running. A monitoring system would be able to detect the error and restart the single node at runtime. This happens without interfering with the execution of the nodes in the critical path.
Fantastic. Thank you so much, Marco. So for the joint solution, like we said, we have the Apex.AI, the SYSGO, the Renesas. So Apex.AI, what we bring to this is the proven solution from robotics to automotive. Okay. So taking the robotics ROS and extending it for automotive and safety. So robotics encountered and solved many of the same challenges 10 years ago that automakers are now dealing with as they work to create the software-defined vehicle. So what we do is we take all of the best things that are best about ROS and then extend it. We extend it with a modern development process that is extended to automotive safety, the best-in-class software development tools, again, with automotive safety. We abstract the complexity of all the underlying hardware and software. So if you want to very quickly move to other platforms and swap in other sensors and actuators, we make that really quite easy. And it's deterministic, real-time, and automotive functionally safe. And within our Apex.OS product, we have the Apex.Middleware, which is also available as a separate product. And this really gives you this vehicle communication that via the API, working with the different automotive domains, working with the different technologies, the CAN bus, the DDS, the SUM-IP, the MQTT to the cloud, all of these things. And so we really make it quite simple for your developers.
PikeOS is both a Type 1 hypervisor and an RTOS. It is ASIL D certified as a software element out of context and provides strict partitioning that supports mixed criticality between units. This allows the consolidation of systems that previously required the separation on ECU level. In addition to the safety certification, PikeOS provides security certificates for different standards, like example common criteria. The hypervisor provides the virtualization capabilities for a wide range of guest OSs, like POSIX PSE51, with support of Apex.OS and Apex.Middleware, Linux, including automotive-grade Linux, and AutoSAR. The joint solution will be provided as a pre-integrated package. So it will contain BSPs for the Renesas hardware platform with a wide range of supported devices and accelerators, as well as the Apex.Middleware and Apex.OS software stacks as pre-configured guest OS options. All tools available to the PikeOS development workflow like GDB-based debugging and tracing will seamlessly work with Apex.AI binary artifacts on the Renesas hardware. Reference implementations of a range of Apex.AI applications will be available. PikeOS was one of the first offering SIL4 for the multi-core platforms. It is designed to minimize interference between multi-core applications. Depending on application requirements, PikeOS provides a wide range of communication means for inter-partition and inter-device connectivity. Security for V2V and V2X communication is provided by our security automotive communication platform. Time schedule schemes that can be switched at runtime allow the implementation of fast and secure boot up. For example, PikeOS native can boot in milliseconds and start a CAN stack quickly before booting other guest OS partitions, such as Linux or Android, who usually will need longer boot times. We provide certification kits containing a multitude of components like POSIX, C++, STL, file system, or MATLAB. Each of these components undergo the same strict certification process, providing a consistent interface to our own artifacts.
So this is the Renesas R-Car roadmap that we have developed to support this approach. And our goal was really to cover the entire market requirements from ADAS or basic or entry ADAS up to full autonomous drive level 4, level 5. The first product we have developed are V3M and V3H2, which are actually currently into mass production. But the products I would like to put a bit more emphasis today is about V4H, which was mentioned already in the presentation, which is a device which actually has been released in the recent weeks. So as I said, V4H was released a few weeks ago, and this device has been tailored to address the level 2+ and level 3 market, which is from our view the volume zone from, let's say, 24, 25 onward. So R-Car V4H is available as samples, and we will launch mass production in 2024. And we have already several major OEMs who are committed to this device. A few key features is first about AI capability, which is definitely a key point for such kind of applications for ADAS. So we are performing 34 TOPS, but with an efficiency of 90%, which is quite good. And what is also a big differentiator on this device is the extreme low power consumptions, because we consume for this IP 16 TOPS per watt. We have also implemented an ISP, image signal processing IP, to have a good resolution, to support high resolution sensors, and we have the capability to have parallel processing either for human vision and for machine vision. And this would enable major improvement on the artificial intelligence KPIs. Our SoC is fully developed according to ASIL D process with an ASIL D for the real-time domain. Application core and AI are in ASIL B. This product is developed using the latest 7 nanometer automotive qualified technology, and we can ensure a very low power, and this would enable to have passive cooling, which helps to reduce drastically the BOM. Last but not least, V4H has been developed based on what we call software-first approach with a full virtual platform, paving the way to software-defined car. And finally, V4H is valued by the complemented software offer from Apex.AI and SYSGO.
And what we give you with this solution is we take ROS with the Apex.AI certified products based on the ROS 2 and the ROS middleware, the PikeOS with its safety certification, the Renesas with its ASIL D safety assessment report. And together, all of these products with all of the safety artifacts and all of the traceability, it gives you the solution for rapid development of safe vehicles with a 4-year first mover advantage. And so some key takeaways from today. So one is with this joint solution, we can very much speed your R&D ROS prototypes into production. The development skills will be much easier to find. ROS is taught at all the universities, or very close to all. It's a very strong platform for software-defined vehicle. So the portability, the abstractions, all of these things for rapidly developing robots, we have taken those and improved upon them even further. And all of the virtualization, the Docker, the hypervisor, all of these have been used for so many years in robotics development, and they are now coming to automotive. This gives you a best-in-class hypervisor with our friends at Cisco, so the PikeOS hypervisor for your RTOS, your Linux, your Android. As we said, ASIL D certifiable with all the safety artifacts for all of the components. And with Renesas, it gives you the scalable compute to match your use case. And we encourage you to come meet us and see this and discuss it at Embedded World in June. You can talk with the Apex.AI, the Cisco, the Renesas experts. We will be in the Cisco booth, booth 4532, the Renesas booth, which is especially easy to remember, 1234. And we look forward to seeing you all there. All right, well, with that, I think we are done. So thank you so much, everyone. Thank you for joining us. And again, encourage you to come visit us at Embedded World. It's going to be a really great show, and look forward to working with all of you. Have a great day, everyone.